Good morning, guys. I hope you are enjoying your snow day. We're going to cover the law of cosines today. This is a lot like what we did yesterday, except easier because there isn't the ambiguous case where we had to check two different angles. The difference in the law of sines and the law of cosines is you can use law of sines whenever you have two angles, or together there's two angles, such as you have one and you're looking for one. Law of cosines you'll use when you don't have as many angles. So either you have none and you're looking for one, or you have one and you're looking for a side. If in doubt, try the law of sines because it's easier. If you end up with too many variables when you set it up, then you'll need to try the law of cosines. Same thing with law of cosines. You can't use this. You can't use Pythagorean theorem or trig with this because this isn't a right triangle. This will work on non-right triangles like our law of sines yesterday. There are three formulas here. I would advise you to only memorize one. They're the same thing. They're just set up from each different side. But if you always call your side A and your angle across from it A, then you're fine. You'll see what I mean when we write these problems. Okay. Example 1, you have this tunnel and you want to find the distance. You can view the picture and read the problem here. I do encourage you to work these problems along with me, so type it in your calculator, make sure I did it correct, etc. And to pause it, work it on your own, and then check your work using mine, as well as pausing it in case you need to take more time to take notes. So on this first one, I'm looking for this side, x, okay? If you want to label it like that first equation, then I always call the angle I have A and the side across from it little a. I know that's not what this is labeled as. That's okay, we can relabel it. It doesn't matter what your side B and C are, but note those are the sides that intersect the angle. You do not have to do it this way, you'll pick up. But if I plug into that formula, you can look above. But it looks like this, where these are all sides, and this is my angle. Right there after the cosine is the only time you're ever going to plug in an angle. So if I plug this in, I get the side I'm looking for squared equals the other two sides squared minus 2 times those other two sides that intersect my angle times cosine of my angle, which this has to be the angle across what you're solving for. Right, I'm solving for x, so I use that angle. Now, this whole right side I can type in my calculator. I would advise you to write this first step down. And yeah, we can take it step by step, but there's really no reason to when I can type that entire thing in my calculator. Now notice that is solving for x squared, so this will not be my answer. When I type this whole right side in my calculator, this is what I get. Check me. I'm going to round to the nearest whole number. That does not make sense for my answer, and we can see it's x squared, so when I take the square root, I get 416.8. I'm going to round to the nearest whole number again. Normally your homework or your worksheet will tell you what it wants you to do. So my side, or my length of my tunnel here, if we put it in context, is 417 feet. Don't forget those units. And that's our final answer. That was it. So plug and chug. The formula is a little, I won't say confusing. It looks ugly, but plug in accordingly and solve. Yes, you will need to learn that formula. Okay. Here I have no angles, so I'm looking for an angle. What we would have done in the past is we would have used trig and used our inverse functions. We can't use SOHCAHTOA here because it's not a right triangle. But we're using the law of cosines. We're solving for an angle, so we will still be using inverse cosine. It says I need to find all the angles. I'm going to start with angle A. So if I'm going to start with angle A, then the equation I need to use is with side A across from it. And then I plug in my other two sides. and cosine of the angle I'm looking for, A. Notice I can't just plug in this whole right side because I have an A there that I'm solving for. So I'm going to need to move everything away from it. But you can type this in. Now notice I stopped before the subtraction sign because my negative 2 times 8 times 12 is multiplied on my cosine A, and I can't just break up that multiplication. But I can type in that, and then I can type in this subtraction, and it will still be attached to my cosine A. Now I'm solving for cosine A, so I need to get rid of all this. This is multiplied on, so I'll subtract over first. I am going to get a negative, but that makes sense. And then to solve for cosine A, I'll divide by negative 192. Remember when you round to carry it out pretty far to a few places for increased accuracy. I'm solving for A. I have cosine A. In order to undo that cosine, I take the inverse. I'm solving for an angle, so we knew we'd be using an inverse function. Some of you got confused yesterday because we were always using sines. Remember, this isn't opposite, hypotenuse, adjacent. Here, when I'm using law of cosines, I'm always using cosine. And when I take the inverse, I get 17.6. We were solving for an angle, so my unit is degrees. That's angle A. That does sound like a reasonable angle. It might seem a little bit small, but if you look at my picture up here, this is a very acute angle, and 17.6 is correct for angle A. Now, it says to find the angles, so I need to continue on and find a couple other angles. I want to find B. Now, you could do it in any order, but I'm going to go for B. So I erase my work, and now I'm going to work from B. So if I'm looking for angle B, I need to start with a side across from it. And then I plug in my other two sides, squared, minus 2 times those other two sides, and then cosine of the angle I'm looking for. Again, I can type this in my calculator, so I'm going to do 5 squared plus 12 squared. You could do that in your head separately, that's fine. And then, sorry, my heat just kicked on if you heard that. 120 cosine B, again I need to subtract the 169. And I'll need to divide by the negative 120. There was no rounding there, that came out exact. And then to solve for the angle, I take the inverse cosine. And I get approximately 28.96 degrees because I was solving for an angle. And again, if I look at my picture, that looks pretty reasonable. It is an acute angle. Now, there's 2 of my angles. It told me to solve for all 3. It would be nice, you know, to go in and do law of cosines again for good practice, and then to check my work by seeing if they add all up to 180. But that's just more work than you need. You can subtract these from 180 to solve that last angle. And I got 133.44. And if you look, that looks reasonable because it is obtuse degrees. And I'm done. I solved all 3. So when you're solving for a side, you can throw that whole right side in your calculator. When you're solving for an angle, you will have to subtract over and divide and then take the inverse. Okay, area of a triangle. Yesterday we worked on an equation. Area equals 1/2 AB sine theta. you can still use that. This is a different way. It looks long, but sometimes it can be easier. So we're going to practice one this way. On your homework, your worksheet, your cosine worksheet, and your sine worksheet will have you find area. You can use either formula. I'm fine with that. So what this is called Heron's formula. And it has my S, A, B, C are their variables in here. Well, A, B, and C are still sides. But S is what's called the semi-perimeter, semi being half. So it's the half perimeter. And you'll see this here. A businessman wishes to buy a triangular lot, because who doesn't, right? In a busy downtown location, the lot frontage on the 3 adjacent sides are, and it gives you 3. I did not give you the picture because I wanted you to draw it. So it's some triangular lot. We don't really know what it looks like, but I can draw a picture just to kind of help me out here. Okay, it says find the area of the lot. Well, if I'm going to use this formula, the first thing I'm going to do is find the perimeter. I'm going to throw this in my calculator. And my perimeter is 468 feet. But for this equation, I need my semi-perimeter, which is 1/2 of that. Now, notice in their equation, they do 1/2 A plus B plus C. I did A plus B plus C, and then I'm doing 1/2 of it. Order of operations, it doesn't matter what order I do that in. And so my semi-perimeter is 234 feet. And then I'm just going to say A, B, and C. It doesn't matter which order. So for my area of a triangle, 1/2 my semi-perimeter times my semi-perimeter minus one side, my semi-perimeter minus the second side, and my semi-perimeter minus the third side. For some problems this might be shorter, for some problems this might be longer. Here I don't have to find a theta though in order to use the A equals 1/2 AB sine theta. In the other problem, in the other formula we used yesterday, we had to find a theta, or if you're given a theta. So what I would suggest is that if you're given a theta or given an angle, use the formula we did yesterday. If you're given the sides, use Heron's formula. Of course, it's up to you. Both of them work, as well as area equals 1/2 base times height. This is just easier when you're given these sides and none of them are your height. Okay, so I'm typing this in my calculator. I'm using not a good calculator. You should be using your graphing calculator. And so it's taking me a while, but you should be able to throw this all in one strand. And okay, after typing that in my calculator, like I just said, this calculator is a struggle. I realized I found the perimeter wrong. If you were adding that with me like I asked you to, you had already found that mistake. So I went in, the work's right here, but that's 720. When I divide by 2, I get 360, and so I just replace those in my formula. When I type that in my calculator and take the square root, I get 17,451.65-ish. And so the area of this lot is approximately 17,452. My unit was feet, but it's area, so that's feet squared. And that's your final answer. Okay. Sorry for that mistake there, but other than that, plugging in is pretty easy. Now I'm going to, this is the last one, I know it's out of order, example 3, but what I'm going to do is I want you to pause this and I want you to draw a picture and work this on your own, and then start it back and check your work. Okay, you can see I finished here by solving for side A first up here, plugging in the whole right side of my calculator. Then I solved for angle C. I had to subtract and divide. Then I solved for angle B by adding them up and subtracting from 180. And there's my triangle. Check your work. The key is golden. I'm going to ask you for that in a second when you take the online survey that is required. And that's going to be how I know you listened to this. So the key, the word is golden. Golden. Okay, thanks. Have a good rest of your snow day.